All right. So let's start the session today. First and foremost, thanks everyone for joining in. Today's session is a session on agentic AI in banking and risk management, as you all know. And to take us through this session, we have with us Ritesh. So just to briefly introduce Ritesh, Ritesh has done his CFA, is an MBA from IIM Calcutta, is a BTech from IIT Kanpur. He has also earned the Sustainability and Climate Risk certification from GAC. His diverse industry experience includes leadership roles in Yes Bank, RBL Bank, Barclays, where he successfully managed large credit portfolios and teams. Ritesh is an accomplished trainer and educator with more than 2,000 hours of training sessions delivered over the last 10 years. With 15 plus years experience as a banker, specializing in credit risk, trade finance, project finance, he brings a wealth of practical insights and hands-on experience to his training programs. He is a member of the IMT Center of Distance Learning, Ghaziabad Board of Studies as well. So presently, he works as a freelance trainer after his long corporate experience with various organizations, including our institute, Indian Institute of Quantitative Finance, College of Supervisors, Reserve Bank of India, Emeritus, and where he's a program leader in AIML. He is also trains in Crisil Academy as well, right? Great learning and teaches a course on digital marketing and finance and for many other educational institutes, right? So that's about Ritesh, and I'll hand over the session to Ritesh. But before that, maybe just to uh, give a basic lowdown on how we would go about in the session. So as you all know, uh, the session would be for about 1 hour, where we'll be discussing the topic, followed by questions and answers. And then yeah, so please feel free to type in. We would want the session to be interactive, so now or later or during the session later on you can discuss your questions. You can type in your questions anytime you have any other question or query, right? So we want the session to be interactive, so please feel free to type in your questions. Let the questions flowing. Right, with that, I'll hand over the session to Ritesh. Ritesh, first and foremost, once again, thank you for joining. It's always great to have you. Let me make you the presenter also. Yeah, so I've made you the presenter. Whenever you're ready, please feel free to start the session.
Am I visible on the camera, Nitish?
Yes, yes.
Okay. Okay. So, hi everyone. Thing wrong with my camera. Just a sec. Okay. So, hi everyone, and a very good morning to all of you. And thank you, Nitish and IIQF, for inviting me over for this session on agentic AI in banking and risk management. Before we start with this, I actually want to present you with a scenario. Suppose there is a bank, and the bank has an AI powered transaction monitoring system which detected a coordinated fraud ring which is operating across, say, 20 countries. The alert came at around 2:47 in the morning when no compliance officer was awake. By the time the fraud team arrived at 9 in the morning the next day, the system had already blocked 32 transactions, suspicious transactions, uh, aggregating to about $150 million. They had filed preliminary SAR, or what you call a suspicious activity report, with FinCEN. They froze the implicated accounts, and they had already drafted an escalation memo for the senior management. All this done in 9 minutes. Compare this with a human analyst team working the same case, where they have to pull the transaction records, where they have to cross reference the accounts, where they have to write the suspicious activity report. It would have taken a minimum of 3 to 4 working days. And in those 3 to 4 working days, a very bright chance is that the money would have moved. Now, why did I show this to you? If I ask you, what is the difference between what I just showed you versus the fraud algorithm that probably your bank has been using since, say, 2008 or 2010? When I ask this question to people, they will normally say that the new system is faster, the new system is smarter, the new system can work on more data points. But that is not the key. The key insight is that the algorithm that your bank used in 2008, it waited for someone to ask what to do, whereas the algorithm that I'm showing you now decides to act. And that is what agentic AI is all about. If I compare the kind of headlines that you would have in 2005 versus, say, 2024 or 2026, in 2005, we would have said that the bank has deployed a system to detect fraudulent transactions. That would be a rule based machine learning. Or why 2005, even 2015? That would have been a rule based machine learning system where the system will give a score to each transaction and a human analyst will work on that score output. Okay. The system will not do anything else. On the other hand, if you look at the 2024 or 2026 headline, the headline is that the bank's AI detects a fraud ring, it blocks transactions, it notifies the regulator, and it updates internal policy even before the staff come to the office. This is an agent. It is perceiving a situation, it is reasoning about it, it is taking multiple sets of actions, and it closed the loop without being instructed at each step what to do. And that is all what agentic AI is about. Having looked at this, if I have to explain to someone what agentic AI is from first principles, someone who does not know about AI at all, who is not machine learning or AI savvy, how do I explain it to a layperson? I would say that you think of the evolution of agentic AI in four stages or the four layers. The first layer is what we call the tool. Think of it like a hammer in your house. You pick up the hammer, you swing the hammer, you put down the hammer. The hammer does only one thing, and only when you use it, it does nothing more. So the analogy is that of a physical hammer. In artificial intelligence context, you can think of the tool as a traditional machine learning model or a basic calculator. So you feed it the inputs, it produces an output, and then it stops. It doesn't have any memory or context between different users of the tool. It cannot initiate anything. It cannot use other systems. It just responds to the exact query that it receives. That's the tool in the artificial intelligence world, a traditional machine learning model or a basic calculator. Because this session is about banking and finance, so if I can give you a banking example, it is very similar to how you pull your CIBIL score. You submit an application or a request, the system will return a bureau score, done. It does not then go back and check your GST return or cross reference any other database. It just answers one single question. That's it. That is the layer 1. In layer 2, what we call automation or RPA, robotic process at automation, that is what happened. What do we mean by that? If layer 1 was a hammer, think of layer 2 as a factory conveyor belt. It has been programmed to execute a sequence of steps, a fixed sequence of steps, fast, error free, and consistently. But the moment something unexpected happens, say you place a box of the wrong size on the conveyor belt, or you put a label which is in a new format, the entire thing comes to a halt. In the world of automation and artificial intelligence, we call layer 2 as RPA or robotic process automation. It will automatically, a software bot is there which will log into systems, which will copy the data, which will fill the forms, which will send emails, following a well written script. It is very fast, very reliable for work which is predictable, but it has zero judgment. Zero judgment. To give a banking context, think of a natch where you have these ECS mandates. So when you take a loan, normally what the NBFC or the bank will do, they will ask you to sign a natch mandate, which means you don't need to initiate the payment of the loan every particular day of the month. The system will pull funds from your account directly. So think of how Natch mandate gets processed, or how there is a reporting system which pulls data from the core banking system and generates some reports. These are all automated scripts. They run on a fixed time schedule according to a fixed rule. You change anything in between, and the robot or the bot or what you call the RPA, that will just break down. That was layer 2. In layer 3, you have the large language model or the LLM powered assistant. Now it's important to understand that layer 3 and layer 1 both are tools, but there is a big distinction between the two. And the distinction is that layer 1, which was the hammer, can only do one thing. It can just hit something. Similarly, a basic machine learning model can only do one thing. It can score a transaction, it can classify an image, but only one thing. But it does not have the ability to have a conversation, to understand the context, to interpret ambiguous instructions, or to reason across multiple steps. And that is where layer 3 comes in the picture, where you have a large language model like a chat GPT, a Gemini, or a Claude, which is fundamentally different in many ways. Number one, it is built to be a general purpose tool. The same LLM can read a credit report, it can write a credit summary, it can answer a question about the debt service coverage ratio, it can draft an email to a borrower, it can explain the Basel III capital regulations, all within the same model. In the traditional world, you would have needed a model for each of these activities. So, generality. The second distinction is what we call the capability of working through multi step problems. If you ask the LLM to evaluate a borrower, it will consider multiple factors simultaneously. It will apply a weightage to each of these factors, and it can produce a nuanced conclusion, not just a plain vanilla numerical score. And the third, and I would say the biggest distinction is natural language processing, where the model is able to understand context and ambiguity. If you tell the LLM, if you ask the LLM, is this particular borrower stressed? The LLM is able to figure out that this question, whether the particular borrower is stressed or not, means something different if the borrower is a large corporate and something different if the borrower is a MSME farmer. And the LLM is able to understand that context. So LLM is very powerful, but it has a very critical limitation. It only responds when you ask it. It does not have any persistent memory across sessions. It cannot go by itself and fetch live data from, say, a GST network. It cannot send an email. It cannot update a system. You have to ask it. It will do what you have asked. It will stop. Think of the LLM like a very brilliant consultant or a subject matter expert who is sitting in a room which has no phones, no computer, no internet. The consultant is incredibly knowledgeable, brilliant at reasoning, but the consultant is completely dependent upon you to bring every piece of information to them, and they are unable to do anything beyond your instructions or without your instructions. That is the LLM powered assistant. And layer 4 is the agent which changes everything. Let me explain, or let me try to describe that through a scenario. Suppose you are a junior analyst where the bank has asked you to do something and given you a laptop. Suppose your boss tells you that this is my list of top 50 borrowers across the bank. I want you to monitor this top 50 list for any stress signals. If you find anything concerning, you have to investigate it fully. You have to prepare a report and you have to alert me. And then the boss leaves. And you, the analyst, goes to work. You will pull all the relevant data, you will run all kinds of queries, you will do analysis, you will read news reports, you will do some Excel based number crunching, you will write the report, and you will send the alert if there is one. The analyst was able to do all this without someone telling them at each step what to do. They were just given a general mandate. That is what an AI agent is. The core of the AI agent is the LLM itself, which is the tool. But then, how does an AI, how do you transform from the LLM to a full fledged agent? Three things: something called tools. By tools, I mean the agent can use external systems. They can query a database, they can call an API, they can run a Python script, it can send an email, it can read a document. The LLM alone cannot do any of these things. The next important aspect is memory. The agent tends to remember what it has done within a session, and it can be given access to what you call the longer term memory store. What I mean by this is that the agent is able to build on its own prior steps. And the most important one, autonomy loop. The AI agent can keep working, and by working, I mean reason, act, observe the results, reason again, and keep that loop running until the goal is achieved. The agent does not stop after one iteration of the loop. So think of the AI agent as a system which is able to pull data inputs from the external environment, which is able to reason about what to do using an LLM, which is able to execute actions via tools and APIs, and finally, able to continue the loop autonomously until a goal is achieved. And all this without requiring a human instruction at every step. Okay. So this is how the LLM, which is at the core of everything, gets transformed into an agent which can be incredibly useful. Now, if someone asks me, what are the ingredients of any AI agent? Because the ultimate objective is to be able to build an agent. See, from first principles, every AI agent, and this is irrespective of what is the use case for that AI agent, every AI agent is built from the same five components. And if you understand these five components, it will help you evaluate the agent, deploy the agent in your bank, and also monitor the whether the agent is working well or not. Those five ingredients are: number one, the brain, which is the large language model, a Claude, a Gemini, a DeepSeek, a ChatGPT. Memory. So the brain is providing the education, the judgment, and the reasoning ability. Memory, vector database, conversation history, retrieved documents. Think of this like your notebook, your past files, institutional memory. Tools, APIs, databases, code execution, web search, email systems. This is where Bloomberg Terminal, Krilsi database, Krillic database, rating agency portals, MCA or Ministry of Corporate Affairs portals, email tools, Excel, they will all come into the picture.
Can I interrupt a minute, Ritesh?
Yeah.
Somebody has asked what
Yeah.
is LLM. So he has no idea about LLM. So briefly, before going forward, if you can just like quickly update. Yeah.
So think of an LLM as a chatbot. So if you have used ChatGPT earlier, which I am sure many of us here would have used, a ChatGPT is actually an example of what you call an LLM. So LLM is a chatbot. Now what it does essentially is you ask it a query. Okay, you ask a query to the LLM, and depending on your query, the LLM will give you an answer. And that answer could be in text, that answer could be in image, that answer could be in the form of an Excel file. It all depends on what your query is. In technical terms, an LLM is a neural network which has been trained on vast amount of data to simply predict what will come next in a sequence. So the idea is that the LLM is a neural network which has the capability of natural language processing. That means you can converse with the LLM in natural human language, whether it is English, whether it is Hindi, whether it is German, and it will give you a reply in the same human language. Does that answer the question, Nitish? Hello.
Yeah, sorry, I was on mute. Yeah, I think so. So essentially, yeah, somebody's asked. So yeah, I think that's good enough for the time being. Please carry on.
Yeah, sure. So you had the brain, the memory, the tools, and then very important aspect without which the agent cannot function as an autonomous agent, what we call the planning, the chain of thought. COT means chain of thought reasoning loop. This is like the analyst's work plan. First, I will check X, then I will check Y, then I will decide what to do next. Planning is very important. How you plan, because most of the real world phenomena or use cases will require some kind of a planning in terms of a sequence. And finally, you have the autonomy, which means the agent is able to continuously run without human interaction or human instruction or human intervention at each step. It will work throughout the night without any supervision from a human analyst, and it will deliver the finished output. That's it. So these are the ingredients of any AI agent. The exact implementation will vary from use case to use case, but this is the blueprint. Now, if I have to give you an example of how traditional AI is different from agentic AI, I just prepared a slide here. Here I'm trying to show you how a bank used traditional AI earlier and what is going to change with an agentic AI approach. So suppose let's assume HSBC Bank and they do anti-money laundering or AML investigations. Now in the traditional AI, and by traditional AI I mean till 2022, the AML system of the bank would be a rule-based model which would flag the transactions based on predetermined criteria. The predetermined criteria could be anything: transaction amounts which are above a certain threshold, transactions being done to high risk countries, any particular patterns in the transaction. It will apply that criteria and flag a transaction. And when the flag gets triggered, a human analyst will receive an alert, and then the analyst will take over. The analyst will pull the full transaction history. They will research about the counterparty or the customer in multiple databases. They will check the various sanctions list. They will review the customer's KYC file. And finally, the analyst will decide whether he or she wants to file a SAR, or what you call a suspicious action report. It will take at least 3 to 6 hours per case. And since you have thousands of alerts daily, what happens is if you go to a bank where you see people file the paper based suspicious action report, you will see a pile of paper, and most of them are either closed with minimal investigation due to capacity constraints, or they just keep lying there for months and months. With the agentic AI approach, the moment the flag will be triggered, the AML agent will autonomously, without any human analyst, pull and read the entire transaction history for the flagged account. It will query the sanctions databases. It will search news reports for any adverse media coverage on the involved parties. It will do a cross-referencing with other flagged accounts to identify any network linkages. It will assess whether the pattern constitutes a reportable event, and if yes, then it will draft a structured suspicious action report and route it to a human analyst with a full investigation package. Which means the human being is receiving a finished investigation, not a raw alert. and the overall review time drops from several hours to say 30 minutes on the max, depending on the case, of course. This is how traditional AI compares with agentic AI. Or to give you another example, say a financial advisory tool deployed in a bank like Morgan Stanley. Now, someone will say, oh, this tool simply answers questions like Chat GPT. So, how does it become an agent? The key distinction is if you ask Chat GPT a question, it can draw only from what it was trained on. That means any version of the LLM is knowledgeable only up to a certain date because that is when it was last trained. It cannot access your internal documents directly. But if you ask the Morgan Stanley system a question, it simply does not reply from memory. It plans. It will decide that in Morgan Stanley's database, there are 100,000 proprietary research documents. It will decide which of those research documents are relevant for this query. Then it will act. It will retrieve and read those specific documents in real time using a tool, what we call a vector retrieval system. Then it will reason. It will synthesize the retrieved information with the client's portfolio context. And then it will act again. It will proactively it will proactively give follow-up recommendations that the advisor did not even ask for specifically based on its reasoning. This multi-step loop, that means you plan, you retrieve, you read, you synthesize, you recommend, got executed autonomously without any human intervention at each step. This is the behavior of an AI agent. The advisor did not tell the system to first search the documents, then cross reference the client portfolio, then generate the follow up recommendations or ideas. The agent decided that workflow itself. So, Morgan Stanley actually has launched, I believe, a system like this, which is built on GPT-4. And the objective of that AI agent is that it is able to access the entire breadth of intellectual capital that Morgan Stanley has as a financial institution, and then it proactively recommends what to do. Okay, so this is the comparison between traditional versus agentic AI. Now, I've been talking about autonomy. Again, there is a very common misconception that agentic AI means something which is fully autonomous. It is autonomously making final decisions. You would have read about that dispute or the argument between the US Department of Defense and Claude recently, where Claude said that they are not going to allow their models to be used for two things: one for mass surveillance of American citizens, and secondly for fully autonomous weapons. So normally we think AI agent means fully autonomous AI making the final decision. When it comes to banking and the banking AI agents which are in production environment today, most of them are not fully autonomous. They are tightly supervised. So I've tried to show here in the slide different levels of autonomy. The first level is what you call assisted, where the human being has complete control. Agent is only summarizing the data, providing a recommendation, final decision taken by the human being. Credit report summary, early warning signal dashboard. Level 2, semi-autonomous. Agent will investigate, decide, and act on different tasks. If that particular task involves any step which is irreversible, that means which cannot be reversed, then it will ask for human approval. So human being again will approve the action before execution, like the AML or anti-money laundering, suspicious action report drafting, pre-screening of loan applications, validation of documents. At the third level, you have what we call supervised autonomous agents, where the agent is acting independently on defined tasks. The human being is only reviewing the log, not the individual action. So human being is only monitoring the outcome subject to periodic audit. These are the fraud detection systems in real time using pre-approved rules, KYC renewal workflows, supervised autonomous. Level 4 is fully autonomous, where the agent is acting, deciding, and closing the loop on its own. No human intervention at all. The only purpose of human being in the scheme of things is to set the goal and periodically review exception reports whether the agent is working well or not. This is not happening in banking today. I think some high frequency trading algorithms or high frequency trading setups use it, but this is not happening in banking. 90% or 95% of banking agents which are in production today, they operate at level 1 or level 2. And don't think that this is a limitation. It is a deliberate design choice based on the regulatory requirement. The goal of the AI agent in banking system is to put a finished analysis in the hands of the human decision maker faster and with higher quality. The objective is not to remove the human being from the room altogether. Okay, so it's important to understand this concept of autonomy as far as AI agents are concerned. Then I'll give you some idea about how to build an AI agent from scratch. The analogy is that of a kitchen. Think of a restaurant kitchen, whether it's the kitchen of a dhaba or whether it's the kitchen of a five-star hotel. All of them have the same structure. Similarly, every AI agent has the same structure. So to put the kitchen analogy, in kitchen, the order ticket comes in the agent, a trigger or an input will come, which will wake up the agent. It could be a new loan application, it could be a daily schedule, it could be a breach of a threshold. That is the trigger. And the chef will read the order. Here you have the LLM planner, which will interpret the goal and decide the sequence of steps or actions to be taken. Then you have the station cook who will execute the task. Here you have the tools and APIs. Each tool does one specific job. You have a tool to query the core banking system. You have a tool to pull the bureau data. You have the tool to send an email. You may have a tool to check the GST network data. Once the cooking has been done, then someone will check before serving to the customers. That is the human gate or the guardrail, where you do a quality check before any consequential output or action goes out. And finally, dish will go to the customer. That means you have the output, you have the report, you have the credit memo, an early warning system alert, a blocked transaction, and so on. The engine inside every agent, and I showed this in an earlier slide, this React. Okay. By react, we mean reason plus act. And this is the repeating loop which drives every agent behavior. Every AI agent is simply running some version of this loop where the agent will first think, what do I need to do to achieve this goal? Then it will act. It will call a tool, query a database, run some code. Then it will observe, what did I get back? What does it tell me? Then it will think again, what does this mean? What do I do next? Act, observe, act, observe. The loop will continue until the goal is achieved, and finally you will get the report as the final output or the final result. Okay, so these are so this is how you build any AI agent. And then, as I told even earlier, these are the 5 components of any banking AI agent that you need. The first component is to decide upon the trigger. The first component is the trigger. What will wake? Okay. What will wake the agent up? The trigger could be a fixed schedule trigger. Something has to be run every morning 5 o'clock. It could be an event, a new loan application in the core banking system. It could be a threshold breach, any account where the average monthly balance goes below falls by more than 50% in a quarter. It could be an API call from another system. So that is the trigger part. Then you have the data connections or the tools where you have core banking system, Sibyl, Experian, Equifax, that is the bureau score, credit history. You have the CRILC database of RBI where you get to find the account conduct of different borrowers. GSTN network, which gives you the GST return data, turnover, filing compliance. The MCA 21 site, Ministry of Corporate Affairs, where you are able to get director details, shareholding, auditor, financials, some kind of a screener where you will get market data, shareholding analyst reports, and there could be other APIs which essentially fetch any news media coverage, adverse media coverage, court filings, regulatory actions. So you have the trigger, you have the data connection, okay? You have the trigger, you have the data connection, you have the reasoning engine. The reasoning engine is the prompt. This is where your domain expertise gets encoded. The prompt will tell the agent what role the agent is playing. Say the role could be a senior credit analyst, what the goal of the agent is, what tools the agent has access to, and how does the agent need to reason about different combinations of the data, and what is the format in which the agent's output should be delivered. A well-designed prompt is the fundamental difference between an agent which produces generic output versus an agent that thinks at par with your best analyst. And finally, you have the output or the human gate, the fourth component. The idea is that every banking agent should have a defined output format. It would be a report, it would be an alert, it would be a draft memo, and a defined human gate, the point at which a qualified human will review the output before any irreversible action is taken. This is mandatory from a regulatory perspective and also a requirement from a internal risk management perspective. Okay. And finally, what I will do, I will show you one particular use case of fraud detection and how can you build a or how can you design an agent for fraud detection. See, first of all, you have to realize that traditional fraud detection is not enough. So even before machine learning came into the picture, we used to have fraud detection which was driven by static rules, pre-formulated rules. Say one rule could be that if the bank customer is making a payment of more than 50,000 to a new first time payee to whom he has never transacted with before, raise an alert. Fraudster comes to know about this rule, they will simply split the transaction into 49,500, 49,500. The rule fails. That is a fundamental problem. Then people started doing machine learning based scoring of each transaction. Again, what the model does, it scores every transaction in isolation. What I mean by that is the model understands that a 2.5 lakh rupees transfer at 3 in the morning to a new payee is statistically unusual. But the model does not understand that the customer is a night shift doctor who frequently makes large transfers, or that this new payee to whom the remittance is being made is actually the same entity under a slightly different account name. It does not have any investigative capability. That is why traditional fraud detection is not enough. How will a fraud detection AI agent perform the same job? It will have an entire investigation list. The difference between traditional ML fraud detection and a fraud detection AI agent is when the suspicious transaction gets flagged, the agent does not simply score and move on. It conducts an investigation very similar to what a human analyst will do, but much more faster. So it will have a complete instruction investigation checklist. Is this payee to whom the remittance is being made or fund transfers are being made, is this a new payee? If new, then how new? What is their registration history? How does the transaction amount look or compare relative to the customer's 12-month behavioral baseline? Is the timing of the transaction anomalous, hour, day, frequency pattern? Have we seen the device identifier and the IP address on this account before? Are there any structuring patterns, meaning any other transactions in the last 60 minutes from the same account? What is the customer's overall risk profile? Tenor, segment, historical disputes, and does the pay account show any network links to previously flagged accounts? Very, very important in fraud detection. Why? Because fraudsters never act alone, they always act as a cohort or as a group. So it will do the entire investigation, and based on the investigation results, the AI agent will decide whether it wants to block the transaction, whether it wants to flag the transaction for the human review, or whether it wants to let the transaction go. Okay, so I have a small workflow which I had prepared. I will show it to you. So this is a workflow which will show you how the AI agent will actually do its work. So there is a dummy transaction 2,40,000. Pay is Raj Enterprises new. Time is 3:17 in the morning. Device is unknown. First time. Location is Nagpur. Velocity 4 transactions in last 8 minutes. Customer profile salaried 65,000 per month. Average transaction 18,000, has been the bank's customer for 3 years. I will launch the investigation agent. Agent will do an amount baseline check. It will say that the pay is a new pay, first ever payment to this from this account, no prior transaction history. Then agent will reason new pay carry inherently higher risk. Then it will do timing analysis. 2,40,000 significantly above their 12-month average transaction of 18,000. Then it will do an analysis of the device and location. Transaction initiated at 3:17 in the morning. Only 2% of these customers' transactions occur between 11 p.m. and 5 a.m. So it's a timing related anomaly. It will look at the velocity pattern. This device has never initiated a transaction on this account. Location in Nagpur does not match customer's registered address. It will look at the customer's risk profile. 4 transactions in 8 minutes detected on this account. Combined value of transactions in last 8 minutes 6.8 lakhs. The agent will reason that high velocity multiple transactions are a hallmark of account takeover fraud, where the fraudster is trying to drain the funds quickly before the victim notices and blocks the account. Then it will do a network graph check, where the customer profile is a salaried employee and the agent will reason that the customer's risk profile does not match the transaction pattern. Why is a salaried customer making multiple large late night transfers to new payees from an unknown device? Then it will give a verdict. The pay virtual payment address is linked to 3 previously blocked accounts. Cross network analysis shows pay VPA is appearing in fraud ring mapping database. Associated accounts were blocked for a structured fraud in October 24, and the agent will block the transaction. On the other hand, if it was an ambiguous transaction, 85,000 pay is Krishna suppliers, time 11:45 in the night, registered device, location Mumbai, home city, only one transaction in the last 60 minutes. The agent will do the same investigation. But now the agent will reach the conclusion that probably it is not a fraud, or at least outrightly does not look like a fraud. Some human being has to check this. And if it's a low risk transaction, say 12,500 being paid to Reliance Jio, known merchant at 2:30 in the afternoon, it does the investigation report. Same thing, amount baseline check, timing analysis. But now you can see, look at the reasoning. Reliance Jio is a known merchant, established relationship, 12 prior successful transactions on record, reduces pay side risk. Amount of transaction within normal range for this customer, no anomaly detected. Transaction happening at 2:30 in the afternoon within the customer's normal active hours, no time related anomaly. It will do all this, and finally it will say no network links found, pay account has clean network graph, no links to flagged or blocked accounts. The verdict is it's a low risk transaction, let it pass. So I'm just trying to give you an idea of how the AI agent will ultimately work in a real production environment. So that's all that I wanted to discuss. If there are any questions, I'll be happy to take them.
Wonderful. Wonderful. All right. So, yeah, there are a lot of questions. But before we go to the questions, maybe just allow uh, very briefly to like talk about uh, what we are trying to do in this fields of advanced analytical areas of finance, right? So, and then we'll go to the Q&A.
Sure.
Just give me a All right. Okay. So very quickly, for those who have joined for the first time in today's webinar, I mean, you all, I mean, I represent Indian Institute of Quantitative Finance, and we are a specialized education body conducting education and training in this specialized areas of finance, quantitative finance, financial engineering, risk management, algorithmic trading, AI, and machine learning applications in finance. So we have been founded by pioneers in India and top experts from the field of financial risk management, financial engineering, investment banking, so on and so forth. Right. So for people, both students as well as professionals, we do have multiple courses that actually we do for people specifically interested in entering into the advanced analytical areas of finance, particularly in financial engineering, quantitative finance, risk management, algorithmic trading, and then of course into data science, machine learning applications in finance. So we have this what we call open house uh, online live lecture based certificate programs. Certificate program in financial engineering, quantitative finance, risk management, postgraduate program in algorithmic trading. So these are people who want to understand the specific fields, or if somebody wants to go deep into understanding machine learning, data science, and their applications in finance. So we have courses in AI for finance. We have courses only specifically for machine learning for finance, for data science for finance, and for those who want to who already have background in data science, machine learning, and want to understand the applications of different applications of machine learning in different areas of finance, so they can do for short super specialization modules like generative AI for finance, or AI for trading, or AI for risk management, AI for derivative valuation. So these are specialized modules for understanding the applications of machine learning in different and in different areas of finance, right? But for if somebody wants to do these modules directly, then they need to have prior background in data science, machine learning. So there are multiple courses that prepares you for different areas, pertaining to the industry, particularly in advanced analytics related to financial engineering, quantitative finance, derivative valuation, pricing, risk management, and machine learning, data science, and their applications in finance in different areas, right? So, I mean, these are courses which are all live online weekend programs for people. You can be uh, either a professional or a student. You can do this along with your job or along with your full-time degree, and I mean, essentially, and that prepares you for those specific roles. I mean, you can go to the website and check out the testimonial pages, not for any advertisement purpose, but for you to understand how professionals over the last 16, 17 years of being in our existence, right? How people have utilized our courses to further their careers or make careers in the field of quant and related areas. So there are a lot of students who have kind enough to share their thoughts. And I mean, the courses, of course, since we have we are the oldest quant body in India, right? So we do have a strong industry connect, and I mean, there's a strong placement support program as well for the students who do our courses. And in fact, I mean, the support system starts as soon as you start interacting with us, even before you join our course. So I mean, you can take help of the domain experts to even I mean, seek their guidance in deciding the right course, right career path. So there's a career counseling even before you join the course. Then once you join the course, these courses are invariably all taught by people who are in leadership position in the industry, particularly in quant or risk management or ML areas of finance. And I mean, these are people who themselves are part of the recruitment system, right? So they help you in understanding the subjects in context of how it is applied in the industry. And I mean, so essentially, like, again, you can discuss whatever your questions, queries with them. So these are mentors who are themselves leaders from the industry, right? And then once you complete the course, as I said, there's a dedicated placement support team who helps you in the entire process, starting from your resume building, interview preparation, LinkedIn profiling, sending your resume, getting your interview call. So they help you in the entire process, right? Yeah, so that is there. And I mean, I'm not elaborating this. These are some of the target companies. It can be hedge funds or international banks or investment banks, all the asset management companies, fintech companies. It can be the financial software product companies, stock exchanges, consulting firms. It can be the central banks and regulators. It can be even the IT companies. So there are many companies where actually one can target the jobs if somebody is doing these courses. These are again a very small list of like overview of the kind of profiles. I'm not going deep into that. I mean, anybody having an interest, they can of course. Right, so they can connect with us. I mean, connect with us in through our phone numbers. You can email to us, and we'll be very happy to discuss. Right. So anyway, with that, I mean, I'll go to the questions. There are many questions that has come. Right. So let's go back to the questions. Okay, Ritesh, if you are ready, I mean,
Yes, I'm
maybe
there.
I'll collate the questions for you one by one, and then I mean maybe you can answer them one by one. Okay. So first question, Chirag, is not a question; it's a statement. Okay, Chirag, I hope you uh, understood about how AI agents work in finance. Any other follow-up question? Please feel free to type. Okay, thanks, Tapan. I hope you had a good understanding. All right, Ghanesham, thanks for your background. All right, okay. All right. So the first relevant question is from Anant actually, right? He has mentioned that is this workflow that you have shown, right? We need to initially define so that agent can follow those, or how does it work? Hello, hello, Ritesh, am I audible?
Yeah, Ritesh, can you repeat the question? Sorry, I lost you for a minute.
Oh no, no. What I said was Anant has asked actually that whether this workflow that you have shown is this something that we have to define, or like again, how does it work?
I showed a generic blueprint. These are the building blocks that you will follow for any type of agent. But if the specific question is who will actually define the workflow, then the answer to that is it will slightly depend on the type of agent. So, for example, there are agents which are prompt based. Say an
Right.
agent that you make in Gemini or the agent that you make in Claude.ai. So here the domain expert will define the workflow entirely through the system prompt. So for example, you will say first check the GSTN, then cross-reference the core banking system, then check the CRILC database, triangulate the signals, and then produce a risk rating. The sequence is the workflow. Developer is not involved. The credit analyst who knows which data sources matter and in what order is the one who is building the agent. Okay, so that is why uh, something which we should realize when it comes to AI agent is the edge is not the capability to code. The edge is to have an understanding of domain. So domain knowledge is the hard part when it comes to agentic AI, not the ability to code. So these are prompt based AI agents. Then you also have code based AI agents like a LangChain agent. There The domain expert, that is the banker or the risk manager, they will specify which tools are needed, what the agent will check, in what sequence, what will be a red flag look like, what the output should say, and then the developer will code that or translate that into Python functions. They will connect the real API, they will deploy the agent on a server. So in a code based LangChain agent, the domain expert's input will come first and matters more. The coder or the developer cannot build a good EWS agent without a credit analyst telling them what stress signals they are looking for. And then you also have a third kind of agents, which we call the visual workflow agents, say an N8N, where the operations or the business team will define the workflow by dragging and connecting the nodes. Again, no developer or coder is required for the workflow design. IT may simply be the IT team will simply required to set up the N8N server and connect the internal APIs, but the logic, what will trigger the agent, which data to pull, what will continue, what conditions will route to an alert, that will be defined by the person who owns the process. So uh, the answer to that is three different ways of defining the workflow. Either the LLM will do it through a prompt, or it would be a code-based thing, LangChain, or it could be a visual workflow N8N, where the operations or the business team will define the workflow. I hope that answers your question to some extent.
Right. I hope that answers the question. If you have any follow-up question, please feel free to type in, and
Okay.
we'll try to take it up.
I'll just can I make a closing remark to that question?
Oh, yes, of
Uh,
course, please.
the closing remark to that question is that the most common failure when it comes to AI agents is because technical teams tend to dominate the entire workflow, because then what the agent is doing, it ends up technically functional but practically useless. And that is why AI agents are so important, because now your ability to code, forget about whether it matters or not, it is not even required at all. What is required is the domain expert, the risk manager, the credit analyst, the operations person, the business person, the compliance officer, who is the primary author of the agent's logic, which tells me that every single person who is sitting in this webinar right now is qualified to define an agent workflow for their own domain. You don't need to learn any fancy coding for that. You just need to write down your own expertise clearly enough that either a prompt or a developer in your organization can execute it. That's all.
Absolutely. Right. So there's a question from Tapan, and he has
Hmm.
asked, please discuss about types of AI. I mean, do you want to, add anything to this?
No, types of AI, I think that's a very different question compared to what we are discussing in this session. But
Correct.
if you talk about types of AI, so you have supervised learning, you have unsupervised learning, you have deep learning, then you have generative AI. So all these things are different types of AI. And in supervised learning, the idea is that the AI system is being given both the raw data as well as the target. That means the label. And the idea is that it will learn the pattern. In unsupervised learning, you don't have to predict anything. You simply have to learn the pattern. Then you have deep learning, where the learning approach itself is very, very different. So by learning approach, you have supervised learning, unsupervised learning, reinforcement learning, and of course you have neural networks. And then you have generative AI, where the idea is not to uh, understand or predict something, but to generate more data points of the same type. So these are different types of AI, and probably we can discuss that question offline if required in detail.
Absolutely. Right. So, like going to the next question, which is from Harshavardhan, and he has asked, I'm still confused how I can integrate AIML with my wealth management, or how should I keep my POV for future? Would you like to answer that
So,
question?
so does he work in a wealth management company, or is he asking this question as an individual investor or a person who does investing?
Right. So, Harshavardhan, if you can maybe type in your follow-up on that, actually, what Ritesh has asked.
So in the meanwhile, what we can do, we can try to answer it in some way. So the question is how to integrate AI ML as a wealth manager. Uh, look, look at the wealth management function. Wealth management involves three things which AI is particularly good at. Why wealth management is a good use case for AI? AI is very good at pattern recognition across large data sets. It is very good at personalizing things at scale, and it is very good at continuous monitoring. These things are important in wealth management also. Wealth management is also very relationship driven and very trust based. So the question is not whether the AI can replace the wealth manager. The question is always that AI will end up making the wealth manager much more effective. And to answer it in more detail in terms of how you can integrate it with your systems, see at the first layer, you can use AI to know your clients better than they know themselves, doing client profiling and segmentation. So traditionally, wealth management firms segment their clients by asset under management, HNI, ultra HNI, mass affluent. Using AI, you can do segmentation by behavior, by goals, by risk psychology, by life stage, and all of this simultaneously. So you can do goal based financial planning. The second use case of AI in wealth management is portfolio construction and optimization. I mean, modern portfolio theory doesn't work. Talking about classical mean variance optimization or Markowitz framework, which assumes that returns are normally distributed and correlations are stable, that does not work in the market, especially during stress events. You can use you can use AI there for for regime detection, for factor exposure analysis, for tail risk modeling, for doing robo advisory, which is kind of democratizing the entire wealth management space. And then you can use AI for investment research and due diligence. What will take a research analyst 3 days, AI agent will do in 3 minutes. AI augmented research. Like Goldman Sachs has a GS AI platform which allows the analyst to query 10 years of SEC filings, earning transcripts, and research reports conversationally. That means you will ask the AI system, what did the management say about margin pressure in, say, this quarter, and how does that compare to what actually happened? That will be answered in like 15 to 20 seconds by the AI agent, something that will take a junior analyst many hours to review and tell you. Then you can use AI for uh, as a source of alternative data for equity research, satellite imagery, credit card transaction data, job posting data, social sentiment, shipping logistic data. You can use AI in wealth management for risk management to detect concentration risk, to model liquidity risk, for any behavioral finance related interventions. So all these things, uh, involve use cases of AI in wealth management. I mean, I hope to a certain extent I have been able to answer. If there are any follow-on questions, I'm happy to take them.
Wonderful. There's a general question actually from Mahalakshmi.
Hmm.
She has asked, I want to know many generative AI tools for research and development. So just like a quick listing would be helpful.
Specific Gen AI tools for
Research,
and research in what area?
not mentioned actually, like again, yeah.
Okay, I'll give you some broad idea. Uh, Gen AI tool.
For research and development, she has mentioned. So maybe like again,
Some of them, I'm see, I'm not I'm not very well versed with this, but some of them which I have come across, there is something called a semantic scholar. This is an AI powered academic search engine, which at least they claim that they cover almost 200 plus million papers across all disciplines. And this semantic scholar is different from Google Scholar in the sense that it understands meaning and context. Google Scholar only works on keywords. So, for example, in Semantic Scholar, if you say that you are searching for credit risk contagion in emerging markets, then it will give you papers which discuss the concept, even if they don't use the same keyword or even if they use a very different terminology. So if you use credit risk contagion, it will give you papers which talk about spillover effects, which talk about systemic fragility, which talks about cross border transactions. Okay, so that is one thing. And what Semantic Scholar also does, I have just used it once earlier, that every paper has a one sentence AI generated summary. So, you can look through many papers in a matter of a few minutes. So that is one. There is one more, I think, R&D tool called Elicit, Elicit. This is an AI research assistant which is specifically designed for literature review. So, I mean, you can ask a research question in plain English, like what is the evidence that ESG or environmental social governance scores predict credit default? So, Elicit will search the entire academic databases, it will retrieve the relevant papers, and it will build a structured table which shows you the name of the paper, the title, methodology, sample size, key finding, and limitations. I think it's a great tool. It will extract a specific data points from papers and organize them into a comparison matrix, something that you will, I mean, take 3 weeks for you to do. It will be done in a matter of a few hours. So this is again very good for systematic literature reviews. These are the two I am aware about. And Perplexity, of course, a lot of people use that. Perplexity AI. So these are again to answer research questions. There are some tools which people use for hypothesis generation. The idea is, can AI, instead of researching work which already has been done, can AI generate new research hypothesis itself? I'm not sure how good it is, but I have seen examples where people have been using the LLM itself for brainstorming about hypothesis. Okay, and these are the ones I'm aware about for R&D. And if you have to do an R&D related to any database or something, not data analysis, a lot of quantitative data related R&D, then there is a very good LLM called Julius AI. I think it's very, very good when it comes to data analysis itself. So you can simply upload a CSV file, you can connect a database, and you can ask questions in plain English. It will write and execute the Python code, show the output, and explain the result. So whenever you do exploratory data analysis without writing any code by yourself, uh, it's very useful. I've used Julius AI personally, and I find it very useful for researchers who are kind of, domain experts but may not be very good at programming. These are some that I know about.
Wonderful. I hope that helps. That is very useful information, I think, for most people. All right. Going to the next question is from Ajit, and he has mentioned, are we feeding the critical data to third-party APIs? My concern is about data security of end users.
Are we feeding critical data?
Yeah.
No, we are pulling critical data from third-party APIs. What does he exactly mean by that?
No, no. So I think what he tries to say is, I mean, as far as I understand, is, I mean,
Mhm.
any critical data, are we actually feeding to third-party APIs? Because these systems, all the, I mean, all this AI tools that we are using, these are at the end of the third-party tools, right? So are we
Okay, okay.
feeding the critical data
Yeah,
to the
yeah,
third parties?
yeah. I understood what he's saying. So
Yeah,
probably, Nitish, what you are trying to say here is that if the banker is typing the borrower's financials into, say, a chat GPT, or the agent is calling an external LLM API with CIBIL
correct.
data, with GST network returns, or client portfolio details, then that data is leaving your institution's network and traveling to a third party server. Correct?
Yeah, absolutely. So he says that my concern is about data security of end users.
I think that's a very, very genuine, very pertinent and relevant question. So the question is, once it leaves your institution's network and goes to the third party server, what happens to the data there? Uh, I think the answer will depend on which product you are using, what are the terms of usage, and what is the configuration. So I'll give you just a couple of situations to summarize what I mean by this. The first situation is, Say a credit analyst will paste a borrower's profit and loss statement into chatgpt.com, or a wealth manager will upload a client's portfolio into the free version of Claude.ai, or a risk officer uses Gemini to summarize a due diligence report which contains actual names of clients. Now, what can actually happen to that data? If you look at the terms of usage, say OpenAI, ChatGPT, both the free version and the plus version, they tell you clearly that they will use the conversations to train the future models unless you opt out in the setting. Or look at the Claude.ai, Anthropic says that they will review conversations for safety and improvement. Or look at Microsoft Copilot, there also they look at the process data under the terms of the consumer, individual consumer, or terms of the enterprise. I think the critical point here is, if you are accessing it as a consumer, individual consumer, your data may be stored, reviewed by humans, and used to train future models. Okay, you have lost control of data. And this is not hypothetical. In 2023, I understand that engineers at Samsung, they pasted some proprietary semiconductor code into ChatGPT 3 times before the company discovered it. And that code potentially became part of OpenAI's training data. And since then, Samsung banned all external AI tools in their premises. So that is the first situation. The second situation, this is a very dangerous one when you are a individual and you are pasting data into the LLM. Relatively safer one is when you are using it through enterprise API, where zero data retention is built in. So what a bank's team, IT team will do, they will integrate the Anthropic API or OpenAI API into an internal application under an enterprise agreement, which will have explicit data processing terms. So for example, when it comes to Anthropic, you can have an enterprise API policy which says that they will do zero data retention. Inputs and outputs will not be stored and will not be used for training their models. The fundamental difference between the two situations is when you use the model as a consumer, individual consumer, the products are free because your data has value to them. Enterprise APIs are paid because your data is yours. So the provider is only selling the computing power, it is not harvesting information. So under the enterprise API terms, the LLM is like a calculator. It does not retain your data. And this is again required from a regulatory standpoint. And the third scenario is when you do a private deployment or an on-premise deployment. This is the most secure thing, where the bank will run an open source LLM like a Llama 3 or a Mistral or a Phi 3 on their own servers, either on premise or in a private cloud. In that case, no data will ever leave the bank's network because the model is entirely running within the institution's infrastructure. No API call to any external server. Trade off is open source models are generally less capable than the frontier commercial models like GPT-4 or Claude. Okay, some model quality will be lost, but the bank will have complete control and security over their own data. I think some Indian banks, they actually are running pilots which are based on llama based models on their private cloud infrastructure for internal use cases, precisely because they don't want to send customer data outside their network under any terms. I hope that answers your question to a certain extent.
Right. I hope that answers the question. And if you have any follow up, please feel free to ask. But I think that was a very good answer, actually. Okay, going to the next question. Anup has asked towards the end of the session, can you please tell us some applications of agentic AI or this kind of areas in credit risk? Um, so building an example, I think actually like in a short span of time would be a little challenging, right, Ritesh?
I mean, see, I've already told you the basic steps that you need to take, but I will give a more, I think, useful answer to this. See, when it comes to agentic AI in credit risk, from a high level perspective, I will essentially categorize credit risk into five very different stages, and you can build an AI agent for each of these stages. Okay, the first stage is where you do credit origination and underwriting. So what happens there is that a retail loan application might take, say, several days or a week or two to be processed because it is being processed sequentially. Okay. What the agent will do, it will run all the underwriting tracks simultaneously. KYC, bureau check, income, property, fraud, and it will deliver a finished credit memo to the human officer. And the officer will decide and review. The agent will only investigate. Okay. Real world examples for these would be, say, HDFC Bank's 10-second loan for pre approved customers, SBI's YONO platform automated underwriting for personal loans. So, this is an intelligent loan processing agent. Then you can also build a new to credit assessment agent, because a very large population in India does not have a bureau file. They don't have a civil record. So, traditional underwriting cannot assess them. So you can make an AI agent for that, or you can make an AI agent for document intelligence. If you're doing a project finance deal or a large corporate loan, you have thousands of pages of documents, project reports, due diligence reports, legal agreements, environmental clearances, technical feasibility reports. Reading them takes a hell of a lot of time. Okay, JP Morgan, for example, has already come up with something called a contract intelligence or coin system, which processes around 12,000 commercial credit agreements per year. Then, beyond credit origination and underwriting, you can use AI agents in portfolio monitoring and early warning systems. You can use AI agents for stressed asset management and resolution. So, you can build an AI agent whose purpose is to investigate NPAs and propose resolutions. You can create AI agents for credit risk modeling and stress testing, where it will build a full credit risk model PD, LGD, EAD for IFRS 9 or Basel IRB. It will do data preparation, feature engineering, model training, validation, documentation, full model development cycle it will go through. And then finally, you can also use AI agents for credit risk governance and reporting. A regulatory reporting agent, you can have a credit committee preparation agent. So these are the different areas in credit risk where you can build an AI agent. Again, I told you the building blocks will always be the same. The good part here is these days you don't actually need to be very good at coding to build it. What you really have to understand is how the domain works, what are the critical steps, what is the sequence of steps, because in most of the enterprise setting, the LLM based AI agent will not be enough. You don't want to leave the things to the LLM to figure out. You, as the domain expert, will specify what is the sequence of steps that you want to be followed. If you are good at coding, or if you have an IT team, you can use a LangChain based agent. If you don't want that, these days you have visual workflows. N8N is a great example of that, where you simply create a visual workflow and the entire coding will happen in the background and you will have an AI agent in your hand. So, I mean, when you tell me that, can you give me an example of how an AI agent works? One way to answer that question is it doesn't matter, because, anyways, coding will not be done by you. Depending on your use case, you need to know how to specify the workflow, and the agent will get its own life. I hope that answers your question.
Yeah, I think so. Any follow up, please feel free to type in. Uh, there's a question again from, I mean, I think we have answered this to a great extent, but again, anything that you want to add? It's a question is how can we frame our prompts to get the best of such activities, for example, for financial analysis? And I think the answer would be almost same, but still, like again, anything you want to
I
add?
think for that, see, there are many different approaches to writing prompts, and I think the question is very valid, but probably I cannot describe the answer in detail in such a short span of time. We need to have another session on that, but just search for the different ways to format prompts, because for most of the people, why you are not able to harness the capability of the model is because you don't know how to write the prompt. Okay, so this is about prompt engineering. So just go and read about what are some good prompt engineering techniques, how to write good prompts, and there is tons of material available on the web.
Absolutely, absolutely. It will. So there are a lot of materials already, and we can study from that, right? But yeah, I mean, the general things remains the same. I mean, if you know the domain, you can actually like again maybe frame the questions for
So
your work.
and just to give you a pointer as to how you can go and search, see some of the techniques, the core techniques. I can just talk about that in this Q&A session. See, one technique is what you call role-based prompting, where you assign the model a specific identity with defined expertise, defined experience, and perspective before asking it anything. Like, and remember, the simpler your prompt is, and the vague, and the more and the more generic your prompt is, the quality of the output is also very generic and very average. The more specific your prompt is, that is why prompt writing is not something which happens in one step. So, for example, if I use LLMs extensively, to be able to write a good prompt will be at least a 25-30 minute job, because you will execute the prompt, review what the output is, then go and refine the prompt. The good part is once you have created a good prompt, it will become a part of your library which you can use many times. So role based prompting is one technique. Then you have something called few shot prompting, in which instead of describing what you want, you will show the model examples of exactly the input output pairs you expect. The model will learn the pattern from the example, and it will apply to any new inputs. For example, uh, you will tell the model, the LLM, classify new headlines as positive, negative, or neutral for credit risk assessment of a steel company borrower. And then you will tell the model that you have to use a certain format, and you will give examples of what a positive headline looks like, what a negative headline looks like, and what a neutral headline looks like. Then the third very important popular technique is what you call caught or chain of thought prompting, in which you instruct the model to show its reasoning step by step before giving a final answer. If you force the model to explicitly show you the reasoning that it has engaged in, it dramatically improves the accuracy of the model on complex tasks. So you have caught-based prompting, that is very popular. Then you have structured output prompting, in which you exactly specify the format, the structure, and length of the output that you want. You will go to a great extent, you will take a lot of pain to exactly create the format, which thing you want as a header, what should a table look like, which thing needs to be presented as a bullet point, limits on words, what it should include, what it should exclude. Once you have given it a structure, what will happen is you will get consistent answers every time. Then you have constraint and boundary setting based prompts, where you explicitly tell the model what not to do, what assumptions not to make, and what to do when it encounters uncertainty. So these are different techniques of prompt engineering. I'm just giving you broad pointers. You can go and research about them. Tons of material available on the web.
Absolutely. All right. So we are almost 10 minutes past time. So now there are still a few questions that are there, but I think the answers that you have given broadly covers most of the stuff. So now, like again, maybe we can start going through the rest of the questions quickly. I mean, unless we
Sure.
find something totally different. Okay. A very interesting question from Anand, and he says that at the real time, what could have been done by IDFC Bank's fraud AI system when 500 crores while money was going missing slowly from government account.
Uh-huh.
So he says that what could IDFC Bank's fraud AI system done when 500 crores while money was going missing slowly from government account? He was talking about the IDFC Bank fraud.
I understood the context. Uh, what so if so the question I think is if it had an agentic fraud system, what it could specifically do. Uh, for this particular fraud, see, I don't know exactly how. I mean, I only know what I've read in the newspapers, but what it could exactly do to prevent in this particular case, I don't know. I mean, exactly how the fraud happened here because I think they had a collusion with the government officers themselves. So you see, a lot of government officers also have come under the net where they were routing the money through different companies. Of course, an agentic AI fraud detection systems might have been able to pick it up. What I can give you a more generic example. So I don't know the exact specifics of how the IDFC fraud worked, but I'll give you a generic example which can answer your question probably in some part. Uh, See, one of the biggest scams or fraudulent activity in India is what you call the GST fraud, the input tax credit scam. So I believe that the GST intelligence units they detected almost 2 lakh crore in suspected input tax credit frauds in a single year. So what will happen in that fraud is because to answer that question as to how an agentic AI system can catch that fraud, you first need to understand how that fraud works. So, like in the input tax credit fraud, firm A will issue an invoice to firm B, but no real goods will move. Firm B will claim ITC of 18% GST on fake purchase. Firm B will issue an invoice to firm C. Again, no real goods move. There will be multiple layers of paper transaction. The cash which has been extracted through the final fake invoice will be taken to a shell company and it will disappear. Okay. Again, in these things, the fraud detection agent can play a very important role. For example, when it comes to detecting shell companies, a simple example is which are the accounts registered within the last 6 months that are receiving large GST refunds. Newly formed companies claiming ITC, that means input tax credit, are a primary fraud indicator. Or which are the accounts where the registered address on the GST, the Ministry of Corporate Affairs website, and bank records are inconsistent? Or which are the accounts where the GST turnover is high, as it is declared in the GST returns, but banking transaction volume is very minimal? Like a company declaring 50 crore in sales in GST should also have commensurate bank inflows and outflows. Or accounts where the director's PAN appears on multiple companies in the same network. Then AI agents can be used to detect circular transactions where money A is paying to B, B is paying to C, and then again C is paying to A. It can be used to find out velocity anomalies. So in all these cases, I'm just giving a very specific example. If I get to know about exactly what were the deficiencies that the people were able to exploit in the IDFC case, then of course we can build an AI agent around that.
Wonderful. All right. I hope that answers your question. And yeah, I mean, next question is from Manas, and again, we have discussed this. What tools are used to build such agents? Anything you would like to add on that?
So I have already said that there are these three types of AI agents. One which you build using prompts. Then you have LangChain, and then of course you have the N8N. But if you exactly want a detailed understanding, again let's go back to the 5 layer structure which I talked about. So layer one pe you had the LLM brain. There you have the frontier model, Claude, GPT-4, Gemini, or you have the open source models like Llama, Mistral, Phi 3. These days, you also have some Indian models like Krutrim is there from Ola, Sarvam AI is there. Layer 2 was memory and knowledge. Memory and knowledge gives the agent the ability to remember across sessions and retrieve information which is beyond its training data. There you will need long term memory or what we call the vector database. That's a core tool. What the vector database does, it will convert documents, policies, and historical data into numerical vectors and store them. Uh, some common examples of vector databases like Pinecone. This is a very widely used managed vector database. Then you have something called VV8. You have Chroma. You have PG Vector. You have Quadrant. Then you have RAG frameworks where the LLM is getting connected to your document store so that the agent can answer questions using your specific documents rather than generalized training data. So RAG frameworks involve tools like Llama Index. There's a tool called Haystack, especially if you have to create production grade RAG frameworks. Third layer was tools and integrations. Remember where you had the database querying databases, calling APIs. There you will need API integration platforms like N8N, or there is a platform called Zapier. You have something called active pieces. These are all the third layer. In the fourth layer, you will need the orchestration framework. Orchestration framework means a framework which will implement the React loop, reason and act. This is the framework that you need to manage the multi-step agent execution, where you will be coordinating multiple agents and you will be handling the complexity of production agent systems. Here in the orchestration framework, you may have LangChain, which is a Python-based framework. You can have LangGraph, which is a graph-based agent orchestration for complex workflows. You have something called Crew AI. Then you have some Microsoft frameworks like AutoGen is there, Semantic Kernel is there. You also have agent builders which do not require any coding at all. A good example is LangFlow. It's a complete visual LangChain builder. Then you also have cloud provider agent services like AWS or Amazon Web Services, Bedrock agents. You have Azure AI agent service. You have Google Vertex AI agents. So in Google Vertex AI agent, you can build agents using Gemini models, connect to the Google Cloud data source, and deploy at scale. And in the fifth layer, you need to put the agent into production. So it's the production infrastructure where you need to deploy the agent, monitor the agents working, and observe it. There you have things like Langsmith. This is the standard platform to observe agents which you have developed using the LangChain framework. You have something called Helicon. Then you have deployment infrastructure like Docker and Kubernetes, Replicate, and then you also have testing related tools like PromptFoo. You have Brain Test. So many are there. I mean, I'm just giving you a list of names which are there. And when it comes to financial services, there are many platforms which are specifically built for financial services AI. Like you have a Mosaic ML from Databricks. This is best for banking. Then you have something called Temenos AI, core banking integrated AI platform. You have something called Setu from Pine Labs. This is an essentially it provides APIs for account aggregator, UPI, and banking data access. So all these tools are there. But broadly, again, tools keep changing. What you have to remember is the five layers: tools for LLM brain, tools for memory and knowledge, where you mainly have the vector database and the RAG, tools for integration. It could be a no coding tool like N8N, Zapier, or it could be a tool where you need a developer. Orchestration tools, and then you have deployment and monitoring tools. These are the these. This is how I will break down the problem and then try to figure out which tool is best for me for each layer. Okay.
Wonderful. That's a solid summary, actually. I mean, thanks so much. I think that was useful. So let's quickly move to the next question, which again to some extent has been answered. I think Deepak has asked. So we have to connect with some large databases associated with ChatGPT or Gemini. Is it always the case, and how do we do that for our LLMs to respond?
मैं समझा नहीं. I did not understand. What does he mean? We have to connect to?
So he has asked, so we have to connect with some large databases associated with ChatGPT or Gemini. Is it
नहीं
always the
नहीं.
case?
No no no.
And how do we do that for our LLM to respond if needed?
See, you have to figure out these are two very different things. The LLM is where the reasoning is happening. The database is where the information is stored. So if you are only asking a generic question which the LLM can answer based on its own training data, that's good and that's well and good. But of course, if you have to pull up data from different sources, वो तो LLM के पास नहीं है ना, that you will need. Or if you want the LLM to work not on its own training data, but based on the documents that you have in your institutional intranet, for that you will need some way to connect to database. So it's not mandatory. It will depend on what you want to do.
Absolutely. Hello.
Ah,
Yeah, sorry, we lost like the last concluding line actually.
no, I said it's not mandatory that you have to connect to an external database every time. It will depend on the
Right.
use case.
Yeah, yeah, absolutely, absolutely. Okay, so moving to the next question from Pankaj, who has asked, could you please provide the outline wherein agentic AI could be used for SME, corporate credit underwriting, or measure the credit risk involved? I think let's skip this question. You have answered this in great detail already. But there are
Hmm.
many questions still pending, so let's like quickly move on to the next question. Okay, let me get to unresolved questions. Some of the questions are actually repetitive in nature, so I'm skipping that. Okay. This is a question from Anu. And what are the possible areas in banking system in India, especially the PSU banks in India, where implementation of agentic AI can improve the efficiency? Okay. Quickly, do you want to add anything? I mean, we have touched upon.
I mean, across the board, everywhere in banking you can use. So, in see any area where you are able, where you have redundancies, where you need to process a lot of information, is ripe for automation. Earlier, you could not do automation because of certain constraints, but with AI coming into the picture, whether it is the front office, whether it is the middle office, whether it is the back office, you can do it everywhere. I mean, you can pick up the reason I'm saying this, you can pick up most of the workflows which happen in a bank, and I can find a use case where you can use an agent AI there. Now, whether you use it or not, of course, will depend on the trade-off analysis, what is the cost benefit analysis, and all those things, what is the regulatory requirement. But if you ask me where all I can use AI agent in a bank, I would say practically everywhere.
Absolutely. Absolutely. Okay. So I hope that answers the question. Next question is from Arun, and he has asked, in the first scenario, is the system block uh, the transaction or human will block? I think he's referring to the first scenario that you described I mean, during our presentation.
Okay, let me open that again. Just a sec. Let me go back to it. First, Madhu, if I remember, I made this point that the human being is in complete control. So all the decisions are made by the human being. So uh, we talked about the four levels: assisted, semi-autonomous, supervised autonomous, and fully autonomous. All production banking systems right now are either assisted, where the agent is like your investigation. You are the Sherlock Holmes, agent is your Watson. Agent is telling you the result of the investigation, but the decision has to rest with you, because that's the regulatory requirement. Even semi-autonomous ones, we have seen semi-autonomous ones, because in some cases, like real-time fraud detection, for example, there you can't wait for the human being to first review and give their opinion, especially in today's digital world. So there you can have a semi-autonomous thing, or even supervised autonomous thing. But for credit decisions and all, it has to be an assisted thing. A human being ultimately has to decide.
Yeah, absolutely. All right. So next question is from Tushar, and Tushar mentioned, I am a student doing bachelor in AI and data science. Am I eligible for algorithmic trading? Yeah, you are absolutely, Tushar. Only thing is, generally for our courses, the minimum requirement is that you need to be in your third year of graduation, and from then on you can apply any time for our courses. And your graduation is very very relevant for algorithmic trading, because data science and machine learning is something which is used heavily in algorithmic trading, and that is something we also cover a lot in our course. So yes, you definitely can. I mean, but generally from your third year. But yeah, I mean, once we you can call us directly, and we can interact more on, and we can discuss whether you are ready for the course right now or not. But in general, your graduation is very relevant for the course. Okay. All right. The next question is from Narendra, and he has asked, "Where do we see the hardest unresolved tension between innovation and AI risk? AI risk in agentic use cases.
Say that again. Hardest unresolved tension
Tension between
between
and AI risk in agentic use cases."
between innovation and agentic AI use
Actually,
cases.
the question is not very clear. Do you want me to ask him to maybe elaborate the question a little bit more?
Okay, I mean, okay, I will answer it in a different way. Uh, Probably let's try to answer what is the hardest unresolved tension in agentic AI, because the session is about agentic AI. वहाँ क्या दिक्कत है उस पे बात करते हैं. Okay.
Right.
Uh, the first tension is of course autonomy versus accountability. Agentic AI, the ultimate goal is to make it completely autonomous, but and that is the value proposition of agentic AI, that it can act on its own without waiting for human instruction at every step. But when it comes to banking, or when it comes to, this is what Claude said to the Department of Defense in US, when it comes to military affairs, or when it comes to banking, uh, every action has a certain repercussion, and someone has to be held accountable for that. So the more autonomous it is, greater is the value of the agent. But the more autonomous it is, the harder it is to assign accountability. So autonomy versus accountability, I think, is a big issue. Then another big issue is explainability versus performance. The challenge is that the most accurate AI models are the least explainable models, and the most explainable models are the least accurate models.
That's correct.
So, if you are doing a credit scoring, a logistic regression model will tell you exactly how the score was arrived at, what was the variable, how much it contributed to the score. If you use a gradient boosting ensemble or a neural network, it can predict the default with significantly higher accuracy, but it cannot produce an equivalent explanation. Or if you have an LLM based agent which can reason, it can reason in natural language, but it cannot guarantee that its reasoning, what is the actual computation it performed to arrive at its reasoning. Okay, that is a big unresolved tension. And I think the third unresolved tension is data hunger versus data privacy. That is, of course, there. Speed versus safety. Speed versus safety, I think, very important. Think about it, an agent which can block 10,000 transactions per second before any human being even gets to see the result will have already caused 10,000 potential harms before anyone even realized that the model has drifted or the model is not working as per the requirement. And finally, a big issue is, which almost all the central banks have already started highlighting, centralization versus systematic risk. The core concern here is that if banks are using a very small set of AI vendors, everyone is using the same model architecture, everyone has the same training operate approach, then the entire financial system is becoming more and more homogeneous in terms of its risk assessment. And what homogeneous risk assessment does, it creates a fragile system. If all agents make the same mistake simultaneously, the entire system will fail. And this is not something which is a far-fetched conclusion. This is not hypothetical. Algorithmic trading systems, which have similar models, they were at the heart of the flash crash of 2010 in US, when in a matter of a few minutes, Dow Jones collapsed by 1,000 points because algorithms, which were all correlated, they responded identically to the same signal. The financial system recovered only because there was a human circuit breaker which halted the trading. Okay, so these are the unresolved tensions, I would say.
Right. Wonderful.
And finally, a very big item on the agenda is efficiency versus human skill preservation. Now, this is much more nuanced, but what I mean by this is every time you delegate a task to an agent, which the agent is able to perform reliably, means the human being is no longer going to practice that task. Over a period of time, the human capability to perform that task, and by extension, it means the human being's ability to verify that the agent is performing it correctly, will degrade, which means over a longer period of time, the institution will become dependent on the agent for functions which no human being can anymore perform from scratch. I think that is a big issue. There, I don't know the answer to this. I have no idea, no clue what the answer is.
No, that's true. I mean, these are anyway ever evolving fields. So, I mean, we don't know how it is,
No, you are
uh, where it is
actually
going.
we are actually seeing this because I also teach at various educational institutions. You look at the quality of discussions in the class that is becoming very homogeneous, and I would say kind of, I wouldn't say shallow in all the cases, but many a times very shallow because everyone is feeding the question in the same chat GPT. There is no diversity of opinion.
Hmm.
क्योंकि सब कुछ चैट जीपीटी से पूछ लिया धीरे धीरे क्या होता है कि यू इवन I mean what happens to it you is initially it's very difficult to draw that line where it is acting as an assistant and where you have become addicted to it.
Correct.
Addiction means that even things that you should have done you become lazy enough to say that boss you do it. No, just tell me what it is.
Yeah, yeah, absolutely.
That is, I think, very very dangerous.
Very dangerous. True. So, yeah, those are the pitfalls actually also. Anyway, I mean, we are already half an hour past time, so we'll quickly go through a few of the questions. All right. Uh, I hope that answers your question to a great extent. So, next question is from Advait. Advait has asked about classes regarding agentic AI in banking and risk management. So, Advait, I mean, we still don't have a specific course teaching agentic AI in banking and risk management. However, we have a course called Generative AI for Finance, where apart from the other topics, agentic AI is also taught in context of finance and banking. So if you're looking at overall understanding about generative AI, LLMs, and agentic AI, so that's a course you can look at. But for that, you need to have a prior background in machine learning, data science. If not, there's a full course teaching AI for finance, all aspects of data science, machine learning, and then this generative AI topics in finance. So you can look at that. So yeah, I mean, you can get in touch with us, and we'll be very happy to discuss. Class timings wise, these are all weekend courses. So depending on the course, it can be either 4 p.m. to 8 p.m. kind of lectures or morning 10 a.m. to 2 p.m. But these are all weekend online live lectures, India time, right? Maybe like again, we can discuss this in detail one on one. I mean, if you have an interest, you can always call us directly, and we can help you out. All right. Mahalakshmi, the certification for generative AI course. Yeah, it's a 3 months program actually, and the course fee is 68,000. There can be certain waivers and all that, so the marketing team can discuss with you. Anyway, like again, we'll call you. I mean, and discuss this in detail. Okay. Uh, there are still few questions that are there. Okay, let me quickly again segregate. Subhajit says it was an excellent session. Thank you so much, Subhajit. Very, very, very appreciated your kind words. Bhupendra has asked, what is vector database? Ritesh sir, any quickly on that?
Sorry.
What is vector database?
Oh, I told you essentially what it does. As I mentioned earlier, it's a part of the layer 2, which is the memory layer of the agentic AI. And what the vector database, I'll give you an example, probably instead of a technical definition. Suppose you're a credit officer and someone asks you, find me all the cases in our existing files which are similar to this new borrower, same industry, similar stress pattern, comparable financial profile. Now, what a traditional database search would do, it will look for exact matches, same industry code, same geography, same loan amount. It would miss cases which are conceptually similar but described differently because it has no understanding of meaning. That is why the human being or a credit officer with a lot of experience is so valuable, because he can look at very different borrowing proposals and understand the commonality between them. What the vector database does, it tries to look for things which are semantically similar, meaning which are similar in meaning, which are similar in context, similar in concept, even if the words which are being used to describe them are completely different. And this is the foundational capability that makes AI agents intelligent rather than merely a fast agent. Okay. I'll give you a simple example of this. See, a vector, we think of vector as a list of numbers. Now, the important insight is I can give you anything. It could be a word, it could be a sentence, it could be a set of documents, images, customers' profiles. Everything can be represented as a list of numbers. And once something gets represented as a list of numbers, you can calculate how similar the two things are mathematically. Intuitively, what does it mean? Suppose every word in the dictionary is represented as a point on a map, a two-dimensional space with an x-axis and a y-axis. What will happen on this map? Words which are related, they will end up close together. So, for example, in this map, banking and investment will be located close, but banking and mango will be located far apart. The distance between the points on the map will represent semantic similarity. That is what a vector database does. The only catch here is, or the where it becomes so powerful is, I told you about two different dimensions. A vector database may have thousands of dimensions in which semantically comparable data is being processed. So that is what a vector database does. So effectively what you do, you first convert text into a vector, which is called an embedding. This is something which is done by a neural network known as an embedding model. And then, you are able to search for things which appear mathematically similar, and then you are able to output. So, uh, I mean, vector databases fundamentally differ from traditional databases. In traditional database, what you are storing is structured data, numbers, dates, text fields, and you search them using exact match. Like in the database, you will go and say, find me all the records where industry is equal to textile or similar to textile. Here you are storing vectors, mathematical representations of meaning. and you are trying to figure out which are the other records whose meaning or semantics is similar to what you are looking for. Okay, so traditional database is good for transaction records, for account level data, for structured reports. But when it comes to documents, policies, unstructured text, that is where the vector database will beat the traditional database hands down. I hope that answers your question.
Yes. Uh, okay. Very interesting question from Neha from PSB. And CSA asked, how can we get the confidence that we as managers are not defeated by AI? Instead, we are making algo in banking.
That we as managers,
We as managers are not defeated by AI. Instead, we are making algo in banking.
oh,
So maybe,
the
yeah,
simplest way
please,
for, huh?
please, sir.
No, you were saying something. Say that, no?
No, no, I just wanted to start the discussion by saying that, like, again, it is not about winning or defeating. I mean, it's like about imbibing the things. I mean, if technology is there, nobody can stop the adoption of technology. It has happened with computers earlier, and so it will happen with AI and the AI agents and all that. So it's like it's about simply imbibing the technology. If we are not imbibing the technology, of course, at some point of time, I mean, we would not remain relevant, right? So that's what I wanted to start with, not a doomsday scenario kind of prediction, but generally that's how things are.
Yeah, I mean, uh, see, I'll start when you use the word defeated by AI. I'm semantically, I think what she is asking about is whether we get displaced or replaced or substituted by
Yeah,
AI.
yeah,
Correct?
absolutely.
Okay. Okay. You see, some people, or rather, a lot of people, will be displaced by AI not because AI is smarter than you, but because either some people will refuse to adapt or the tasks that they perform will become fully automatable. Now, the people who will be displaced does not mean that they are the least intelligent people. Of course not. The people who get displaced are the ones who believe that their value lies in the tasks that they perform rather than in the judgment that they exercise. So, for example, if I'm a freelance trainer, if I believe that I have a mastery of a particular subject, it's very easy for an AI agent to beat me because I can never have that entire depth and breadth at my command which an AI agent can bring. But if I, as a freelance trainer, believe that my actual value lies in you give me a 100-page document, how best to explain it, how to, augment it with real world examples, how to understand whether the students are actually following what I am saying and take corrective action, that means my judgment is becoming paramount. And why this distinction matters so much, and I'm not saying this for the just for the heck of saying it, tasks can be automated. Judgment, I don't think can be automated, at least not now, at least not yet, and not for the kind of decisions that you have to take in banking. Okay. So AI does a lot of things very well. It will beat the human being hands down. Like when it comes to process large amounts of structured data without fatigue. तो जैसे आपको बैंक में बहुत सारे लोग मिलेंगे who are very good at using pivot table. Oh, that skill now AI will beat everyone hands down. Or where you have to detect statistical patterns which are invisible to human observation, or whether you where you have to maintain complete audit trail without any selective memory. These are genuine and significant capabilities. Don't underestimate them. But there are genuine gaps, things which are beyond AI capability. And this is not a temporary technical limitation, it is a structural limitation. The first one is moral judgment, contextual moral judgment. Say a borrower comes into my branch, his factory got burnt down last week because of an accident. His financials show stress. Every rule says classify the account as an SMA account, reduce exposure, initiate recovery. EWS agent already flagged the borrower as high risk. That's where the human being will come into the picture. And the human being will be able to make a contextual judgment which will integrate information that the agent still cannot access. The agent does not have access to reputation. It does not have the ability to read a person, to understand local economic context. The agent cannot measure the human cost of a technically correct decision against the economic cost of a technically incorrect decision. We don't know. Or sometimes the ambiguity is absolutely genuine. In banking, you have to take a lot of decisions which are not well defined. Should I fund this infrastructure project even though the government's political commitment to the sector is not very sure? Or should we give a loan to a first generation entrepreneur when every financial metric says no, but every qualitative signal says yes? Then, building and maintaining trust, customers give banks their money and their financial information because they trust the institution and the people who represent it. Trust is always built between people. AI can support the relationship, it cannot become the relationship. Taking accountability, and this is again why I think AI will never replace human beings completely in banking, at least. When a credit decision will go wrong, someone has to be held accountable. Staff accountability, may you can't bring an AI agent and say that this is accountable. A regulator has to be able to call someone. A board must be able to ask someone to explain. A court must be able to examine a human decision maker, which means human bankers, and not traditional human bankers, but human bankers who also understand what the agent is doing and how to explain and describe the decision that the agent is taking. I think they will always be required in regulated banking. I don't think they are going to go away. But at the same time, will it impact certain job profiles? Of course, it will. I have no doubt about that. Uh, but let's see how it plays out. It also has to do not with what AI is doing. See, what happens is, I'm sure that when automobiles came for the first time, the people who were driving carriages, they would also have been very, very anxious. Now, the point to realize is technology is here. It also matters how you are able to adapt to technology, how you are able to make yourself, you know, indispensable, how you are able to upgrade your skills. Of course, there will be a big disruption, no doubt about that. But people will, in every technological cycle, people need to learn new skills. This is also on similar lines. Every time the doomsday scenario says that everything is going to get burned down, iske baad kuch nahi bachega. It has never happened in the past. Let's hope it doesn't happen in the future as well. But even if it does, it's better to be prepared. Yeah.
Absolutely. Absolutely. Uh, okay, going to the next question, and we'll take two more questions very quickly, and then we'll wind up because it's already we have exceeded time. It's a very, I mean, I think a topic which is of use, very definitely useful, and maybe of like concern to a lot of people as well. And that's like so many questions. But anyway, quickly going to two more questions, and then I think we'll have answered most of it. Okay, so the next question is from Mahesh. Will AI be of great automation within the strict compliant investment banking domain, which primarily deals with private side data like M&A deals, IPOs, etc.? And what tools one need to well learned by any investment banker to mark his excellence ahead of others in investment banking firm? Anything you would like to add specifically for this domain?
No, I mean, to answer that question, it's not about investment banking per se. Anything where you have a lot of data to process and where you have to do the grind work, AI can do it. For example, I still remember something with the Goldman Sachs CEO said, I think it was not this year's Davos, last year's Davos. meeting where he said that uh, when they bring this draft red herring prospectus for companies which are going to access the capital markets as part of IPO, so that entire document that they prepare, he said that earlier a team of 5 or 6 people would need 2 full weeks to prepare that document that we have to file to the stock exchange, which will contain a complete due diligence of the customer, their financial due diligence, legal due diligence, risk, state all the risks. It's a very comprehensive document. Just look at, go to SEBI's site and look at the DRHP that the company files before their IPO. And he said something which used to take 5 working days for 5 people to work 2 weeks. 95% of that can be done by an AI in, say, a matter of not even an hour. And the same is about investment banking. In fact, आप जाके देखो the kind of models. See, investment banking में one of the things that you do is you do a lot of financial modeling. The kind of models that these agents or these LLMs generate these days, the level of detailing and what all you can do is just mind boggling. I don't think that investment banking will be left out. In fact, again, it will be something where AI is going to be used a lot. But that would also mean that now the investment banking analyst will, is, or rather, will be expected to spend more time on understanding the nuances, on going and meeting the customer of, because much of the grind work that you used to do in investment banking, working 12 hours a day to prepare an investment memorandum, doing complex financial modeling, a lot of that will be taken over by the AI. So
Absolutely.
yeah, so
So now a common question is there are two person Aishwarya and somebody else has asked from a career perspective, what's the future of finance professional with the advent of AI?
from the career perspective, what is the future of anyone with the advent of AI? I mean, all of us cannot cannot get into a job. Uh, see, again, on a serious note, the first thing that you have to do is let's get out of the denial mode. It is here to stay. The use cases are very compelling. Even though I agree, a lot of that can prove to be a fad also. Never know, because right now this has become like a technological fad that you have to put the word AI in everything. Uh, but acknowledge that the tool is there to now. See, what will happen is, look at what a finance professional means, and it requires you to have a slightly longer timeline in mind. If you go 50 years ago, or so even say till late 80s, if you were a chartered accountant, you were expected to be able to do debit credit entries in a register and collate everything, do a reconciliation manual. That was your skill set. But once Excel came into the picture, it's not that chartered accountancy as a profession went away. The skill set that is required has changed. And I think to a large extent that is what is going to happen. And why it impacts people so much, because many a times most of us are very, very reluctant to get out of our comfort zone. It's like we have practiced a skill for last 20 years. Now, how do I go and learn a new skill? It's difficult. I don't deny that. But simply because we, uh, you know, uh, we turn away from the sun does not mean that the sun is not shining. So uh, I don't think finance as a profession is going to go anywhere. It will remain. But if you ask me, the skill set that is required from a finance professional, will that go through a significant overhaul? I think yes, it will go through a significant overhaul. So you will still bring a lot of capabilities to the table, but those capabilities increasingly will not be about number crunching. It will not be about able to explain to someone what a net present value formula is about. That capability will be more about whether you know how to use the AI tools, because the organization will have those tools. You have to learn to use them. Today, if you go for an interview, can you tell a recruiter that I don't know how to use Excel? Similarly, you will need to learn how to use AI tools. You will need to learn how to use them for judgment, and you will have to figure out what else you are bringing to the table. So it's early days. I myself don't know how it will shape up. What I only know is that anything which can be automated, if that is your primary skill, then of course you need to learn new skills, whether you like it or not.
Yeah, absolutely. Absolutely. An extension of that discussion actually is another question. So, what are the future job opportunities around financial domain, either around with AI skill set? Which one is actually more crucial for newcomers? What are the kind of skill sets?
Okay, I will answer this in a different way, Nitish.
Yeah,
I don't think the job designation, in some cases, you might have new job designations. For example, people who can look at the ethical aspect of AI models, who can look for explainable AI, who can look for, you know, responsible AI. That's a different issue. What I think increasingly will happen is when you look at the JD, where the company is telling you what all you need to know, the job profile will remain the same, but probably you will need to, ability to learn and ability to work with AI tools is going to become a core requirement. If you are not willing to learn the tool, if you are not willing to adapt to the tool, then of course uh, it will be a big problem. The job itself, and right now, see what is happening is we are still using AI only from an individual productivity perspective. Abhi to
correct.
real game has not even started, where the enterprise will realize that forget about individual productivity. The real game is, can I adapt my workflow itself, my business process itself, to a world where AI is the dominant actor? So most of the
Correct.
roles I think will remain, but probably in a new avatar or with redefined skill sets and redefined requirements. I think that is there. And the most valuable expertise, therefore, would be domain expertise. I think increasingly, see, it has good aspects and bad aspects both. Let's not look only for the bad aspects. Let's also look for the good aspects. The good aspect is tomorrow, it, if you have a good amount of domain expertise, whether you know how to code or not, that will increasingly become immaterial. So people who
Right.
have domain expertise, who understand how systems work, interconnected systems work, I think they will still bring a lot of value to the table. So increasingly, if I can give you a banking example, increasingly, if your core skill is you know how to calculate a current ratio, then forget about it. But if your core skill is to able to understand why the current ratio is coming to what it is coming, what is the nuance behind it, how to interpret it, when can you recognize unusual situations, something which the numbers don't tell you straightforward, those are the kind of skills that will increasingly become more important.
True.
Okay. So I hope we are done with the questions. I think it's 2 o'clock.
Just one more quickly. It's an extension again. So somebody's asked, Vikas actually has asked, explain how much tech skills are required for building agentic AI. So
कुछ
though
नहीं.
you have mentioned that, but again, just a final parting answer.
Very little. I mean, very little, even if I am in this webinar of IIQF. So, I mean, I am a non-technical person myself, and I can tell you that what you only need is some amount of, your ability to come out of your comfort zone, spend some time, try to uh, uh, understand what you are trying to do, or for those of you who have watched Dhurandhar 2, Hosla Indhan Badla. So uh, the frameworks are very, very capable. Believe me, you don't need to be uh, very well versed in coding. You will learn it along the job. But do you need a specific uh, familiarity with Python to start coding uh, an AI agent today? The answer to that is strictly no.
Wonderful. So, with that, I mean, it has been a very long session. There are so many interesting questions. In fact, actually, there are still one or two remaining. So, anybody from whom like the questions we could not answer, please directly email the questions to us, and maybe we will discuss the answers with you. But again, more or less, we have touched upon most of the questions. And again, I mean, Ritesh has answered those questions so wonderfully well. I mean, with so much patience. So thank you, Ritesh, first of
I
all,
will.
for the wonderful session, and
Okay,
thank you so much.
before we end, I just
Yeah.
want to add something to that last question. See,
Yes,
when I
please.
say you don't need to know any coding, that is at level number one. The idea is to motivate the people in this room, in this webinar, that you don't need to be a coder to start your journey. But
Correct.
of course, when you reach the level 5 of the journey, when you are trying to become a judo master, a black belter, when you understand how a full stack development happens, how production systems are created, at that level, of course, you will need to have some understanding. You will need to have understanding. But at level 1, level 2, very little. Just look around you, try to find no coding platforms and take it on from there. I mean, what you lack in experience vis-a-vis coding, you can make up for that in terms of enthusiasm.
Wonderfully said. Right. Wonderfully said. All right. So yeah, I mean, thanks so much for your patience in answering all the questions, and thanks to the participants as well. You have been a lovely audience. It was so interactive, so many questions coming up. I mean, we did extend the session by a long shot, but again, I hope you all found the session to be useful, right? So anyway, look forward to see you in the next webinar. As most of you know, I mean, we conduct this webinars on important topics of, I mean, risk management or trading or machine learning, data science applications in finance, financial engineering, and all relevant areas, algorithmic trading, and so on and so forth. So keep track of our website, our social media handles, and of course, for those who have registered for the webinars, you will receive intimations over emails as well. So, I mean, I look forward to see you in the next webinars. We will be having a couple of them in the next month as well, which will be announced soon. All right. So, with that, I would like to conclude the session. Thanks everyone for joining, for taking your time out on a Sunday, and thanks once again, Ritesh, for your time as well. It was a
Thank you so
very,
much,
very
everyone.
informative session.
Thank you. Thank you. Bye bye.
Thank you. Thank you so much. Thank you.